Well, they often say the jumps are achieved by the magic of YouTube, but this particular case is slightly different. The magic is achieved from losing a hell of a lot of video on a hard disk which I had stored it on, and it just went dead. So we're basically going from the first video, which is, or part of the first video, which is an initial look at this thing, right through to now, when it's complete. At least the electronics is complete. And I guess I'm just going to run you through what was done and what was needed and some of the hassles I came across, and hopefully still make this sort of interesting. One of the first things you'll notice if you look at the first one compared to this one is that the cleaning has been quite extensive. This thing was pretty rusty, and it was quite a job to get this the rust off and get the grey back and protect it from further rusting, but I think it's done. And the result is pretty good for a radio that's, what is it, 68 years old, 69 years old. This thing's from 1948. One of the main problems in this radio, other than capacitors as usual, was that all the wire, most of the wire was incredibly dry and literally just cracked off, which posed quite a danger. So all this rewiring had to be done, almost a complete rewiring. But that does give you an opportunity to make this thing look quite smart. So here's the input voltage selector, and it goes to that dropping resistor over there, because the base voltage for this is 200 volts AC or DC. So literally, if you're using 200 volts AC, wherever you can get that from, I don't know, it goes straight into that bottom pin of that resistor. And the result is that then goes straight into the rectifier tube, which is that guy over there. If you use any other voltage, you get progressively higher resistance drops to drop the voltage down. So that difference between those the bottom two is 50 ohms, and then you got 70 ohms and another 50 ohms. And that gives you that 200 volts of that bottom pin down there. And that is where the voltage is taken off, that one there, 200 volts AC for the rectifier tube. Straight into rectifier. As I said, this is a hot chassis, so 200 volts AC over there. There's another resistor of 275 ohms, that leg there, between there and there. So at the bottom here, you got 145 volts. And that goes to the heater chain, which is exactly the voltage you need. If you sum the heater voltages for all the tubes on this radio, that's what you need. And actually, that's what we get. So it's pretty accurate, actually. More luck than talent, I think, on my part. But all the mains and high voltage wiring had to be redone. Another thing you'll notice is that this is now a 3-wire mains cord. I'll explain that at the end as to why I did that. This does not have earth. Hot chassis, one wire goes to the chassis literally, and the other one goes to the becomes the B plus really. So you can get mains on the chassis, the mains live wire on the chassis if you connect the wrong way around. But I've created a little circuit that protects against that, or at least warns you against that. Anyway, this here, this is the on-off switch. That's on, and then there's a potentiometer as well over there. So if you turn it progressively clockwise, allows more high frequencies through. So one of the legs here switches on the mains, those two wires, the red ones, that's the live. The neutrals are connected together because one of the poles of the switch is completely dead. So you're not actually switching off the poles, and there's an actual reason why I want that to be the case with this little detector circuit for the hot chassis that I'm going to describe later. But all these wires are new, as you can see. They were incredibly brittle. you could not bend them, or you could, but they broke. So that was the main challenge with this whole thing. Then of course there was the cleaning. Those two, those were supposed to be 2 by 16 microfarad capacitors, and what we had in here was 2 by 50, and they were leaky. So I actually restuffed these with 2 by 20s at 450 volts. The reason you don't want a 50 there is because the tube might not be able to handle it. You do have a maximum capacitance after the rectifier tube, which in this case I believe is 22 microfarads on this tube, but I put in 20, which is a little bit more than asked for and a hell of a lot less than what was there. Then if you go across here, you've got a choke over there. That's a choke. Everything was fine, all the tubes were fine except one, which I'll describe in a minute. That's the output transformer. And a tube that I had incredible amount of trouble with, or rather I didn't have trouble with the tube, I had trouble with the radio. This thing was oscillating like crazy when I finally got it to work. And I couldn't figure out why. And what I finally came down to was that the metal shield on this tube was not connected to the pin that it was supposed to have underneath. I think it's pin 6 is supposed to be the metallizing. Now this forms a shield because pin 6 is part of the ground, it's connected to the chassis, and what was actually happening is that this thing was floating. Now what we should do is replace the tube. That's up to my friend to decide whether he wants to order one. What I did temporarily is I wired a wire across there and I connected it to a ground point in the back there, and this thing started singing like a diva. Finally, and I'm talking a few days of trying to figure out why the oscillating was going on, why I couldn't align it. So yeah, you never know what the problem could be. Sometimes it's the least obvious things. Now obviously one of the problems here is I don't have replacement tubes. I don't have a stock of these tubes. This is not my normal radio. The other ones, the German ones that I have, they're all from the 50s and a couple of the 60s. They tend to use the same tubes, those octal 9-pin ones, sorry. And so you do build up a few, spares, and you can just swap it out. With these it's different. I don't have stock. So part of the problem that I had was that I didn't have a tube to just swap out and check it out. I don't have a tube tester because those are practically useless for me. But that would have solved the problem as well. So let's have a look at the underside for a change. We didn't even see it in the old one, but believe me, you can imagine the mess it was in. All these wires had to be replaced. They were the ones that were very, very crackly. A lot of all capacitors, all the film caps were bad. A few resistors, you can see some of them up there that have been replaced. That thing over there, that blue one, that was replaced. That was a 50 ohm, which was open. There was no way this thing was going to work. All the cathode bypass caps were changed there and on that one as well. So you can see quite an extensive amount of replacing that went on. Some of the wires on the horizontal over here were fine. I left them in place. The rest were replaced because they were too dry and cracking. A few difficulties getting into some of those spots to replace the components, but that was finally done. This panel over here has got all the switching on the underside. That was removed and everything properly cleaned up. All the switches cleaned up with deoxit. Potentiometer was fine for the volume control. Pretty extensive cleaning on here. And the knobs were properly cleaned as well. They were pretty grungy. Two sets of dial cords had to be replaced, which if you've done this before you know is not fun. The one was the actual tuning capacitor, which wasn't connected, it was broken, and the other one was the indicator system, which moves the dial point at the top. That was a real bastard to do. Obviously cleaning of the faceplate. Faceplate is fine, no cracks, no chips, nothing. So this thing now is practically a rewire, a rebuild as it were, of most of the components. Coils are all fine. There are a lot of coils on this thing, and the reason is this thing has got a lot of band spreads. So you can see those at the back are coils that you adjust for aligning. Some are oscillators, some are antenna, and these are another complement. A hell of a lot of aligning can be done. Fortunately, it wasn't that necessary, because once this thing got working, everything jumped into place. Everything just popped back. And I checked some of the frequencies by injecting a signal on the antenna, and they're pretty accurate over there. So there was really no need to go too crazy about aligning. I had to align the IF, obviously, quite a few times because of the problem with the oscillation. But other than that, there was not much RF aligning to do. This is really what it looks like when it's ready for a demo. The on-off switch and tone control I've temporarily fixed to the chassis over there, just so we don't have any nasty shocks. And the same applies to the pickup versus radio switch. This is the selector switch for pickup and radio. That's wired, or rather screwed on there, so we can operate it without it flapping around and shorting anything. Just a quick note, this guy had to be replaced. All the wiring in here, which is shielded, I ripped out and replaced completely because it was dry and it was shorting. So that was fun. And that really is a complete restoration. The chassis is not going to be done by me anyway, or rather the cabinet, because it is full of woodworm. And the owner then is going to get a carpenter who's handy at this sort of thing to build a new chassis. It's not that difficult. It's actually quite an easy one. Something else I want to show you before I put it back in. As I said, this is a hot chassis radio, an AC/DC set. So we have a problem here because in Portugal, our mains plugs are not polarized. We can literally plug them in any which way we choose, which means there's no way of guaranteeing which one is live, which one is neutral. And that is a problem because we do not want this chassis to be at live voltage. It's 230 volts, 240 volts over here, and that can really ruin your day. So I decided to put in a little indicator lamp here. And what I've done, if you see this green wire, that is the earth wire from the three wire cord to the mains. It's plugged, this is literally connected to mains earth. And if you see that, it comes in here and it goes into a little contraption over there that's wire wrapped. Okay, what you can see at the end is an ultra bright LED. And the reason it's here is because we can see it through the actual, there it is, through the actual faceplate without it interfering at all, without tuning or without tuning dial or anything like that. So that's plugged in there or stuck in there with glue. And then you got that orange wire, and that orange wire is connected to the chassis itself. That is a ground point in the chassis. So what we have here is, if the chassis is at neutral, then we've got 0 volts going to that little circuit there, and you've got effectively the same voltage, 0 volts, coming from the earth to that circuit over there. So delta V, difference in voltage, practically 0. It'll be a couple of volts maybe. That's the difference between your neutral and your earth. If your chassis is connected correctly to neutral, in other words, if your plug is in the right way. If you happen to flip it the wrong way, then your chassis is at mains voltage at 220 volts or 230 volts. Your earth is at 0, so you've got 230 volts difference going into there. And that is in there, what we have is a lead, a diode, and a pretty heavy resistor, big resistor, 330k. And that's going to allow, at 240 volts mains across this thing, it's going to blink, it's going to light up the LED brightly enough that you can see it through the face panel, front panel. And that'll warn you that you've connected this wrong way around. Now there's another video I'm going to do just showing you how this little thing is done and the calculations and everything else. But for now, I just want to show you that it's there. And I'll show you how it works now. So here we go. I've got the radio off. It's turned off on the on-off switch. I have the mains connected, the plug connected to the limiter box, but I've got the limiter box off, and the limiter box has a double pole on-off switch, so when it's off, at the moment it's off, both the neutral and the live are disconnected. If I turn the limiter box on, you can see what happens. The radio is still connected, the switch on the radio is still off, but I can already see that that LED is blinking, it's on. So that means my mains is wired the wrong way around. Let me show you again, let me put that off. That's off, that's on. Okay, now if I turn the plug around, which I'm going to do, just took the plug out and putting it back in, it's off. I put on the limiter box off, limiter box on, it blinks very slightly, but now it's off. And that means that our chassis is now at neutral, which is what we want. And it really doesn't affect the look of the radio, so we haven't actually drilled anything, made any holes. You know, we've basically kept it as unobtrusive as possible, but it does give us a little indication as to how safe this thing is when I plug it in one way or the other. And that's it for this particular video. There's a speaker which is connected at the back with those two little banana plugs. And I think this thing is ready now for the final video, which is the test that I want to do on the reception.